that is done, if you would be so kind, I hope I don't interrupt anything at the moment. Alright, it's me again. Well, so for you who haven't followed the courses yesterday, my name is Andreas Hiltner. I'm lead Cincom Smalltalk engineer. I did talk about the GUI tools, about the next generation UI, and about the Cincom Smalltalk on the tablet. Now I'm talking about GUI testing. Since we have the new GUI, I need to do quite some testing. And the idea was here not to only have the GUI testing for the next generation UI, but actually for a broader spectrum of applications. So, what am I going to do now? Short overview, the intention, why it was here. Record and replay events with a short demo. Then we go into details for the script clauses. And I also have a class called OS window. Surprise. But in my case here, OS stands for operating system level window. So I'm sure that's quite different from what Firewall has and they were talking about. They are the same? Okay, very good, thank you. So we talk about my OS window here, a script example, and then I'm sure we have time for some questions. As I said, the GUI testing framework was developed not only to test the GUI elements inside Smalltalk, but especially in the next generation GUI, but for all events, for all of the GUI that exists that we have to use and that you can develop with Cincom Smalltalk or any other product out there. Is it written in C#, Java, or whatever? The reason why we wanted that is that our internal testing framework that we bought, or testing tool that we bought quite some years ago, is getting dated, and of course, unfortunately, it's not written in Smalltalk. We couldn't get a hold of all the testing information and the test results, and especially we couldn't run it inside SUnit. So for every build that we do, we run our SUnit test suite, and right now, at least, we have, at that point in time, we had to manually start the GUI test suite with the external tool and basically watch what it's doing. Now, the first idea that I had was, why don't you just record and replay some of the events? And that actually works. So I can record all the keyboard events, all the mouse events that are coming in, and again, not just for my application, but for any application that's out there in the system. But and then you can store them to the file and replay them later on. So sounds like a perfect good way of storing and doing my creating my test cases. In all of the cases, you have to be aware of applications that save state between opening. So if you have something like the calculator actually stores inside the latest interface that you use. Is it for the programming interface? Is it the interface for the regular or statistics? So you need to be aware of that. And you need a repeatable test case, especially for test automation. If all of a sudden the test case or the window that you're supposed to test looks different, then all your tests can go wrong here. Advantages, as we can see in a minute, it's really what you see is what you get. Because you record all the events, you redo it just the way you want it, and you replay it even with timing information. Drawback is it uses absolute coordinates. Meaning if your window opens in a slightly different location, all of your events are slightly off. The recording has to be redone if your application changes, even just a little. As I said, if it moves the location, if anything happens, like a state change, I'll have to redo the whole thing. And some of those test cases can be quite large. So it's a nice idea to have with all of the events that you can catch and everything, but it's probably not the ideal solution. I have a short video here. You will see it. Okay, start logging. This is my first approach of testing the calculator. See this one? Where I go to the decimal first, because I'm switching over to hex, and as I said, the calculator saves the state. So when I open it the second time, it comes up with hex, and I need to check with the calculator first. So now I do a stop logging. I inspect the events. What is it I have? And even for this small sequence, I have 357 events. Most of the mouse move events and hover events. So now let's replay it. You will see 5 plus 5 is 10, so the calculator actually works. It's producing the good result. Now, see, now it's in hex. And now my click here is actually valid, and I need to test it. I need to do it, otherwise it would be in hex mode and it would give me a different result. Not the 4D2 that I expected, but something totally different. So 1, 2, 3, 4, 5, that's keyboard events because the mouse is not moving. It's 1, 2, 3, 9, perfect, works. Alright, very good. As I said, 357 events for this short sequence of tests. If you want to go through all of them and replace the absolute coordinates with relative coordinates, be my guest, but this is really cumbersome, and after just playing around with it a little and using filters and stuff like that, I decided, no, I really don't want to go there. So, what else is there? Well, I can use some scripting here. The script, what should it do? What are the capabilities, what are the classes, what it is that I need? I need access to some windows. I need to find a window and so forth. Mouse input. I need import key to the keyboard. And I need to compare it to something. So I have a class screenshot. We get to those things in a minute. The window itself, what is it that we can do with it? We can retrieve a window with a certain title. We can wait for a window with a certain title to appear. Of course, if you start an application at that moment, it probably takes half a second, depending on your CPU and the number of processes that you already have open, for that window to appear. So we have to wait for a certain window. Retrieve the window at a certain location. You know that the window always pops up at this location. So as soon as it's there, just grab it and then tell me what kind of window it is. Get the Windows menu. And Windows menu here is there on purpose. I can get to any regular style menu, any native menu that you have. Unfortunately, I cannot get to the Visual Works menu. If it's from an outside process, I cannot ask the window if there is any menu associated with that, because it just tells you, no, there isn't. The operating system doesn't know of any menus that are in there. The menus are there, you can see them, you can use them, but that's internal Visual Works handling. I just cannot get it to those things from the outside, which doesn't mean we cannot use them, but maybe in a slightly different way. I can send you a menu item event, so I'll get to that in a minute, to really figure out this is my main menu, and then just go through all the different instances until you hit the one that you actually want to execute and to send it. Retrieve title bar information, which is, for me in my case, I use the close button mostly there, because that's in a lot of ways what people use with most when they want to get rid of the application, when they want to close it, they just click the red X on the upper right corner in Windows. In order for me to, well, I can certainly do that, but either I can just go in and use the offset from the original location where the window is and try to calculate where's my upper right corner and where's my X there. Yeah, I don't want to do that. Personally, I'm just lazy. I just ask the computer, where's this red X button, where's my title bar information, and put the mouse there and then execute the click, and the computer does the rest for me. So I can always, no matter where this machine or where this window is on the desktop, I get always the right location and I always get the click in the perfect location, not off by a couple of pixels. Mouse input, they are the very basics. Left, middle, right button, the scroll wheel, moving the cursor, the hover operation, nothing fancy there. Keyboard input, sending strings or individual characters to any kind of window. Again, it could be the window itself, could be an entry field, could be a number field, could be a list view, could be, I don't know what. Name it and you can use it. Send shortcut, which is actually very different. The send string sends the string itself to the window in keyboard input format. Here with the send shortcut, we do a little translation beforehand and figure out what is the actual keyboard input look like. Control key, Alt key, which one has to be pressed first, which has to be released last, and the keys in between. Special keys. Like left arrow, right arrow, page up, page down, all the stuff all the stuff that you can do with a regular keyboard. Screenshot with or without window frame. The without window frame is something that came up because my colleague Dirk Reisen is using that quite extensively, the test suite. And he always comes back to me and tells me, Andreas, if I just use your code and I run the tests one after the other, they work fine. If I stop in between and probably I resume 20 minutes later, they fail. The very same test, the very same window, it looks and feels the same, and it's, why does it fail? And the first thing I told him, I don't know. Sorry, I didn't. So what we figured out was that he actually uses a different background. So he uses a window theme where he uses different background pictures. And the pictures change every 30 minutes. That by itself is not really a problem. However, in his window theme that he uses partial transparency for title bars. So depending on the window background and the title bar was transparent, it was a different alpha blending, so the title bar was different every single time. So I told him, I'm not going to change it, I'm not going to fix it, we will run to this on a later date. I can guarantee that. So we can shoot screenshots without frames. Problem solved. Works every single time now. We can save the screenshots as bitmap, PNG, and JPEGs. And here are just the different screenshots from the calculator. As I said before, the calculator right now is my test bed, so to speak. It's a tiny little thing, doesn't use that much resources, and it's ready and available for me, and I can do pretty much all the stuff that I need to do. But the nice thing is I can save the screenshot as bitmaps, and that's what I usually use to save all the information and don't try to compress the information into like a PNG or JPEG. Now I can compare the screenshot that I just did with a bitmap that I can load from the disk. Otherwise, how would I compare and see the result of my test? And I save the differences to a bitmap in a file. The frame around here, the black frame, is something that I had to do because white on white, you wouldn't see the window itself. So the real window, the real screenshot actually is the white inside here. And here is the difference. So sometimes you don't really see, you don't readily see what's the difference between two bitmaps. Bitmaps can be large, and you really don't see and recognize where are the differences. So we can highlight the differences, as I said, put it in the differences in the bitmap in a file. So that one is the first one, and here are the other differences. You see the A, B, C, D, E, F are pretty much the same, but the buttons look different here. Well, I have a script here, so don't worry, you don't have to read it from here. That's just impossible. I was sitting right back, and it's really impossible to make it out at all from there. So I need to split it up in a, and show you the individual steps. I hope. Chris, can you read some of it? It's tiny, yeah, sorry. Okay, but I hope you get the point here. So, part one. I want to get a hold of my window. Wait for a window with a title calculator for the maximum of 5 seconds. If there is no window, then I cannot run any tests. If nobody starts the application with that time frame, well, there is no test, so thank you and goodbye. I get the window rectangle, which is not the client rectangle here. The client rectangle is the inside, the window rectangle is the whole entire window, including the frame and title bar. Then I send a delete. Why do I send a delete? Because it saves the state. I just hit the delete button, it just goes away, and I can start from scratch. I send a string 1, 2, 3, 4, 5 plus 9, 0. I can send the whole string at once. I don't have to do any breaks in between. I can just send the whole string, and the calculator does what it wants. I send a return, and then I have a delay. Why a delay? Well, I need to give the window a chance to update itself, to reflect all the changes that I just did. If I go ahead and do a screenshot right away, chances are pretty good that it hasn't been updated, and right away I would get an error and tell me that those screenshots don't match. Next thing is, screenshot, new window, that's the window I just put in. Save client only is true. Again, the problem with Dirk and his title bar. I capture the image, I load the comparison calculator of one bitmap file, and then this little line here compares those two bitmaps down to the very last bit. Down to the very last bit. So I cannot use any JPEGs or any format that has any loss in the encoding and compression in there, of course, so I need to compare it bit by bit, otherwise there is no point, right? If it returns false, so what I do is I save the difference to a bitmap, difference to this bitmap that I just loaded, to a file with a diff01 bitmap extension. So if something else happens, I could put in an exception, I can put in output to a log file, I can do anything I like. Right now I'm just saving the differences for later use and see, are there any differences? If so, what are they? Part 2, the window is still open, but there's something in there. There's something inside, I want to get rid of it. So again, send the delete key. I send a shortcut, Alt 3, and down here you see a send string, 1, 2, 3, 4, 5. This one is a send shortcut. It's a string too, it looks like a string at least, but you send one key. So there's a fundamental difference again. I wanted to point out, this is a string, this is a string, but this one sends 5 keystrokes, this one sends 1 keystroke, basically. Then here, I want to have a left click with, here,
that's the rectangle. That's the reason why I have this rectangle in the first place. I use the origin and an offset. So the next time, the calculator might be in some totally different location, on the second screen, or wherever you like. I don't need to change anything because I'm just working with an offset here. The calculator itself doesn't change. The size of the calculator doesn't change. The window itself doesn't change. Where the window is on the desktop, that might change, but that's why I just asked it, where are you? And I just tell it the offset, and now you click right there. Well, actually left. Delay wait, again, give the window a chance to update itself to make sure all the events are executed. Take a new screenshot, client only, capture, and compare it to the calculator logic. If there are differences, save it to the file diff02. Alright? Nothing fancy there. Part 3. You keep it in that actually left click add is something that you put in the hex. Turn it into the hex mode. Here I click again, wait. Sorry, no. This one puts it into decimal mode. This one here puts it into hex mode. The button is actually higher in there. Again, wait for the updates, compare the screens, so same thing, same procedure as everywhere. Part 4, going to reset the state again. Alt 1 means I switch over to the regular interface that's used. I send delete again just to make sure that you really get rid of it. I send the string 3+4, I do a little wait, you don't actually need to do that, but then I send the string equal. Before I did just a send key return, in here I just send equal, same result. Then I send a delete, and here, down here, I ask the window for the title bar information, what's the rectangle of the close button, I get the center location of the close button, and I put in the left click. And that should close the window. Now, let's see if it works. In this video, the longest time is actually spent for me to activate the test. So I'm going to run this video twice. Alright, activating the test, execute it. Boom, that was the first step. Boom, open the programmer, and 1, 2, 3, 4, 5. Click over to X. Click the decimal, calculator, 3+4, sending the equal sign, 7, and now, boom, gone. And that was with a delay of 2 seconds. So every time I do a delay wait, it waits 2 seconds to do that. Let's do it again. So, as I said, it takes the longest time to get it set up. The calculator is opened, it's on the decimal, 1, 2, 3, 4, 5, the hex. I'm taking screenshots. Now we go in the 3+4, e sending equal is 7, and boom, it's gone. Again, milliseconds, 2000. So 2 seconds for the test. Do we need 2 seconds? No, not at all. The 2 seconds is basically here for the purpose of the demo. You can have half a second, or depending on your GUI, if it's even faster, 200 milliseconds, down 20 milliseconds, 10 milliseconds, but please give it at least a little bit of time to update the GUI. Sending you're posting key events, or keyboard events, you're posting mouse events. That's not a guarantee that the event is actually executed right at that very moment. Yeah, with task switches, process switches from one to the other, just takes a little time. That's why you need some delays there. But you can see that this whole code actually can tie into SUMIT quite easily.
So you can turn that test case into an SUnit test case that you can run every single time. And that's our intention. That's the purpose of this whole framework, at least for us, to tie it into the SUnit framework, to tie it into our existing SUnit test cases that can run against every single build. If you remember GUI testing in the past, at least for me, I was running a QA department for some time. GUI testing in the past meant writing long test scripts that you distribute to all the testers that you have. Meaning you click here, what is supposed to happen, what are they supposed to look for, returning the results. Afterwards you figure out a way to consolidate all the results that you get from your testers and figure out, okay, what went really wrong here? Did they execute the test? Didn't they do it? Did they do it wrong? Something. So we want to have a standardized version of GUI tests that we can run every single time with predictability and actually unsupervised, basically. And if you have been here yesterday when I talked about the system tools, one of the big things for me was I don't want this machine to shut down in the middle of the GUI testing. So that's why I told you the different modes that you can set for the power policies on Windows, telling Windows basically, okay, I'm running now a longer running algorithm, don't shut me down. If somebody presses the power button, okay, there's not much that you can do about it. But at least you can tell Windows, don't automatically power down. And that's the reason the GUI testing is the reason for that. So we start the test, we tell Windows, okay, we're running the test suite now, run the tests up to completion. If anything happens in between, we just log it and handle it later, run the test to completion. Tell Windows, okay, I'm fine, I'm good. If you want to power down now, I don't care, I'm ready. And that's what we run with every single build. Now, questions? Christian? Yeah, Christian?
You mentioned at first about testing visual works.
Yep.
Could you talk about that?
You can do that.
Well,
You can do that. I mean, you have to know the keystrokes. You have to know the keystrokes. You have to know the offset of the different things that you actually want to do. If you have a menu, there's a tool in there, I have to show you, that tells you the screen coordinates of the mouse where you are. And there are lots of tools out there that show you that. You just ask the window for its location. You ask the tool for where's my mouse now. You do the difference and plug it in there.
okay, you just bound to compare bitmaps instead of reading out fields or something like that.
Yes, yes. And I'm not reading out fields here.
I know.
Yeah, I'm comparing bitmaps because reading out fields means that you're actually touching somebody else's control that you don't know if it displays the right thing that compared to what is internally. That's another test. We do that too. But here, that was really the keyboard input, hardware input. It can be, if some other window pops up in between, you're a host, because the thing is really pushes the keyboard, native keyboard events, native mouse events. And I was talking to our friend from robotics. Where are you? There you are, very good. We were talking about hardware events. So that send input format that I'm having right now can also emulate or send hardware events. So if you have those that you need, feel free to use the send input. If you don't, hey. Okay, Chris, you were first?
Yeah, so right now to do a similar setup, we use AutoHotkey as a means of moving our mouse around.
Yes.
One of the problems we run into is the guys who write tests are always subject to the developer removing a button by 1 or 2 pixels. So functionally, the GUI is still the same, but now the test fails because the button moved a little to the left or a little to the right. How would you do?
Here, the window itself is, of course, somewhere on the screen. If you want to get to the button, You can ask the window for its children if you know the button and maybe the content of the button. Is it a bitmap or is it a text? You just go through all the children until you find the button, and then you can also ask the button, where are you on the screen? Where are you on the screen? And then you can just click it right there. So it's not just the top level window that you can access, but every single low level window. Does it answer? Okay, Holger, you will say.
Yeah, we know that you do a lot of